Special product. When finding products of polynomials, it's not necessarily all the time that we use multiplication procedure, the long one, through distributive property, because it will take time. There are some cases where we can simply obtain the product without going through that, and we call them as special products. So think of it like a shortcut on how to get the product of certain polynomials. So our first case is, what if we're asked to multiply two binomials which are exactly the same. So if we have a plus b times the quantity of a plus b, as you can see, they're just the same, and we can apply the concept of multiplication or exponent to that one. So that becomes the square of a plus b, because we're just multiplying a plus b twice. So you can use the concept of exponent for that. Or if we have a minus b multiplied by itself, a minus b again, we can also write it as the square of a minus b. So the first special product is what we call the square of a binomial because of its nature. It's a binomial, and the entire binomial is raised to a power of 2. So what could be the shortcut if in case this is kind of the situation given to you? So if the first step would be to square the first terms. So take note, the first term in here is a. Second term is b, because it's a, then b, plus b. And then here, okay, let me just use another color. So a, uh, our first term is a. Our second term is, it is not just a b, but because it's minus b, so we can take the minus as a negative. So negative b. So first step is to square the first term. So here, our first term is a. So that means the square of a is just a squared. Here, same thing. The first term is a, and the square of a is a squared. Second step is to double the product of the two terms. So it's like saying that there must be a 2 all the time, and you multiply the first term and the second term, which is b. So 2 times a times b, that's 2ab. So always remember there's a 2 all the time, based from the shortcut that we are talking here. And then finally, here, they would not have the same answer because the first place, the second term is a negative. Unlike here, the second term is a positive. So, that's 2 times the first term times the second term, negative b. 2 times a times negative b is negative 2ab. Okay, the third step is to square the last term, similar to what we did in the first step, but it's just that we're using the last term this time, or the second term. So, the square of b is just b squared. Here, though our second term is negative b, but the square of negative b times negative b is just b squared. And then finally, you just have to add the terms obtained in steps 1 to 3. Then that would be the product of our given, the square of a plus b. So it's a squared plus 2ab, a squared plus 2ab plus b squared. The square of a minus b is just a squared minus 2ab plus b squared. So let's try to apply it in a certain example. So find each square of a binomial. So let's say the square of 3x plus y. So it's a binomial, because there are two terms, and then it is now being raised to a power of 2, the entire binomial. So it fits into the special product square of a binomial, the square of a binomial. So our first term here is our 3x. Our second term, our last term is y. So first step, square the first term. So that means square of 3x. Second step, 2 times the first term times the second term. So 2 times the first term, 3x, second term y. And then finally square the last term. The square of y, because that's the second term. Then we just simplify it. The square of 3x is 3x times 3x. So 3 times 3, 9. X times x is x squared. Here, 2 times 3 is 6. Then x times y is xy. Then, the square of y is just y squared. And this is our final answer. So you cannot combine any like terms anymore. Now let's try another example. So we have our b here, which is a square of 5x minus 3y. So the entire polynomial is raised to a power of 2, and it is a binomial, first term, second term, or the last term. But what makes it different from A? A is plus, B is minus. So same step. First step is to square the first term. So the square of 5x. Next step, 2 times the first term times the second term. So 2 times 5x times negative 3y. Because you can take this as negative 3y. Then finally, third step, square the last term. So the last term is negative 3y. You get its square. So, simplify. The square of 5 is 25. Then x raised to the power of 2 is just x squared. 2 times 5 times negative 3. 2 times 5 is 10. 10 times negative 3 is negative 30. Then x times y is xy. Okay, the square of negative 3y. Negative 3 times negative 3 is 9. Y squared is just y squared. And that's our final answer. Let's try to expand the following. So let's check if you can remember it already. So first of all, you double check if it fits into the condition of our special product. It has to be the square of a binomial. And it is a yes. So we can use a shortcut. First, square the first term. This is the first term. Then, second step is to add 2 times the first term times the second term. So 2 times 3a times negative 2b. Then finally, the square of our last term. Okay, there must be a square here. So, the square of 3a is 3a times 3a. So 9a squared. 2 times 3 is 6. 6 times negative 2 is negative 12. And don't forget, a times b. It's just ab. Then, the square of negative 2b. Negative 2b times negative 2b. So, you'll start with the coefficient negative 2. Negative 2 times negative 2 is positive 4. So, again, I will correct this. This is a positive 4. Then, this one, b squared. And that's our final answer. It has to be 9a squared minus 12ab plus 4b squared. Okay, let's have another example. So the square of x plus 1/3. So the square of a binomial because first term, second term. So that means we do the same process. Square of the first term plus 2 times the first term times the second term. So 2 times x times 1/3. Then plus the square of our last term, 1/3. So x times x, or x squared, 2 times x times 1/3. 2 times 1/3 is just 2/3. Then you input x. Then the square of 1/3, meaning the square of 1/3 means 1/3 times 1/3. Numerator times numerator, denominator times denominator. So that's 1 over 9. And that's our final answer. So as you can see, instead of doing the long process of multiplying um, this kind of situation, we can easily get them in a short period of time. That's the use of special product. And for now, it's a square of a binomial. Let's have our last set of example. So we can also use this as a way for us to easily multiply numbers. So for example, we have here the square of 22. So how can we use the concept of square of a binomial to get the product of 22 squared? So remember, things are easier if we're dealing with multiples of 10, if I'm not mistaken. I hope you agree. 22 can be written as 20 plus 2. Okay? So that means it's already a square of a binomial. So instead of saying 19 plus 3 and so on, we choose a number which is a multiple of 10. And the other one, it depends. Whether you will add or subtract to get what is the original. So you choose the nearest multiple of 10. So here, it's 20. So 20, you need to add a 2 to get the 22. So applying the concept of square of a binomial, you get the square of the first term, then 2 times the first term times the second term. So 2 times 20 times 2. Plus the square of the last term or the second term. So 2. 2 squared. 20 times 20 is just 400. 2 times 20 is 40. Times 2 is 80. Then 2 squared is 4. So that's simply 484. Hundreds place. Tens place. And then ones place. So 484. Let's have last example, 59. So as I said, choose a number which is divisible by 10 or a multiple of 10 nearest to the given number. So 59, you might be thinking of 50 plus 9. But 50 is quite far um, compared to 60. So you can use 60 instead. But to get a 59, what will you do to the 60? So 60 minus 1 because it's the nearest. And the lesser number, the better. So, did it fit to the condition of square of binomial? The square of a binomial. First term, second term. So, you get the square of the first term plus 2 times the first term times the second term. So, 2 times 60 times negative 1. And get the square of the last term or the second term. So, the square of negative 1. 60 times 60 is 3,600. 2 times 60 times negative 1. 2 times 60 is 120. Times negative 1 is negative 120. Then the square of negative 1 is just 1. So 3,600 minus 120 plus 1 is 3,481. And that's the answer.